All right, everybody, we're going to talk about cloud formation today. This is Mr. Bremberger, and as well as precipitation. We're going to talk about those two concepts throughout the course of this video, both of which are main components of our water cycle, which hopefully you learned about back in the 4th grade. I know many students over the years constantly comment to me about a song that they once learned. Evaporation, condensation, precipitation on my head. Yeah, that kind of thing. And that's good. I'm glad those songs stick with you, because you're definitely going to need that knowledge or background here when we talk about the following. So, essentially, the two main driving factors or forces behind cloud formation or condensation and precipitation is energy in our atmosphere, which obviously would be in the form of solar energy, that being some infrared radiation, as well as gravity to obviously pull the precipitation back down to the Earth. Now, talking about cloud formation specifically, obviously when we heat up air, that warm air will rise, and any water vapor in it will go vertically in our atmosphere, essentially at some point running into some colder air. When that cold air and the water in it reach a certain temperature, known as a dew point, what will happen is condensation will occur. Essentially, the colder air just cannot hold as much moisture than warm air, so that water vapor will condense or form a liquid or ice crystal. Now, as that cool air, or as the air cools and reaches that dew point, essentially that water vapor will attach itself to any particles that are present in the air. Those particles could be dust, it could be smoke, it could be anything else that is currently as a solid or in a solid state, so that the water can hold on to it. Now, you can think of some examples right now on your own if you want to pause this, because cloud formation or condensation occurs quite often before our own eyes, and some of us don't even realize it's going on. For example, if you're taking a shower and you close up the door, the condensation from the warm air, or the warm air that is generated from a hot shower, will create condensation on cooler surfaces, which could be the walls or even the glass, which tend to be highly visible. Now, when those clouds do form, they form in many shapes and sizes. For example, we have clouds ranging in size from the giant cumulonimbus clouds, which you can see over here on the far right side. Those clouds obviously get very large, and we also have smaller ones like the stratocumulus or cumulus clouds, or even the cirrus clouds in the upper levels of our atmosphere. Basically, we can classify clouds in two ways. Number one is by shape. Your three general shapes are going to be the cumulus variety, the cirrus variety, and your stratus variety here. Cirrus kind of look like wispy horsetails, and you can most often find them in the upper levels of our atmosphere, or they're referred to on this image as high clouds. You also have some mid-level clouds, which are your generally, you can see those as indicated by the prefix alto, your, again, mid-level clouds. And finally, your lower level clouds, which you can see as the nimbostratus variety over here on the far left side. Those are your rainmakers. And anything that has the strato or stratus prefix associated with it are going to generally be layered in some fashion. You can see the different layers or bands here of the nimbostratus cloud. Again, that tends to bring quite a bit of precipitation. Obviously, the big one over here, which generates lots of excitement and can be relatively dangerous, are your cumulonimbus clouds. Now, moving into types of precipitation, again, once we have those water droplets condensing, they're going to reach a certain size that will eventually just be too heavy to overcome the updrafts that we'll find in our atmosphere, and they're going to come crash into the ground, thanks in part to gravity. So now, obviously, you can think of hopefully many different types of precipitation. So why don't you right now go ahead and pause and think about those types. All right, now after a little think time, hopefully you paused. I want to reveal some of those to you. Obviously, the most common one is rain. We also have snow, sleet, hail, and even drizzle is a scientifically recognized form of precipitation. Those forms come in different sizes. For example, your cloud droplet is, roughly 0.05 millimeters in diameter. Your typical drizzle drop is about half of a millimeter in size. Raindrops are about 4 times bigger than drizzle, which would be roughly, 2 millimeters or so in size. And finally, snowflakes are rather large, in fact, being about 5 millimeters on average in size. This according to the Oklahoma Climatological Survey. One often seen type of precipitation is that of freezing rain. Now, some of you probably thought about freezing rain when you're thinking about your different types. It's not formally recognized as one because basically it is rain until it hits a surface, which is really cold. Here you can see, obviously, we have a very dangerous situation because when freezing rain is occurring, what actually happens is the rain will fall in a liquid form, and as soon as it touches a solid surface, it will freeze, thus, obviously, creating dangerous situations because of the amount of weight that can literally add to objects. Here of a freezing rain situation, and by the looks of it, I would not want to be whoever owns this car because they're not going to be getting in for quite a while. Hail also will be registered as is registered as a type of precipitation, and we'll be doing a lab in class as one of our required activities where you'll actually be creating hail in a test tube. Kind of a cool little process. But here in an actual cumulonimbus cloud, you can see how it's generated. Basically, if you start with a tiny water droplet, updrafts of warm air will push that water droplet vertically through a cloud, and it may reach a certain point where gravity will then take over, pull it back down to the ground, and again, more than likely be pushed back up at another point where, as that, increases in altitude, that hailstone will basically run itself through layers of moisture and continuously build layers of ice onto a tiny particle that, again, as it moves through more and more layers of water vapor, can really grow in size. If you were to slice a hailstone open, it would look almost like an onion. So to recap and close out our video on clouds and precipitation, clouds will again form via condensation. Again, when you take the warm air and cool it down to reach the particular dew point of that air, you will have condensation occur because, again, remember, there's only a certain amount of water vapor that can be held within different temperatures of air. And again, when those water droplets become too large to be held up by the updrafts of warm air that hold them at higher altitudes, those water droplets are going to they're going to fall, to the ground, and again, we're going to refer to that as precipitation. So, as always, if any of you have any questions about anything in this video, you need to see Mr. Bremberger as soon as possible so we can get those cleared up and taken care of. So, thanks again for watching. We'll talk to you soon.